Welcome everybody, welcome back to Astronomy for this week. Today we're going to be talking about the evolution of the universe. Now you've been doing some activities on measurements we've made about the expansion of the universe. And we saw that with Hubble's law, that as we look at galaxies that are further away, those galaxies appear to be receding from us faster. And so the measurement that we have of our universe is that galaxies are moving away from us. Now there's a couple of possible explanations for that. One is that we happen to be located at a very special place in the universe, exactly at the center of a giant explosion where everything is flying away from us. That violates something known as the Copernican principle, which states that given that the universe is so vast, the chances of us being in any particularly special place are pretty slim. So us being at the precise center of the universe is probably pretty unlikely. So we tend to kind of throw that explanation out of hand. I mean, we're not at the center of our solar system isn't at the center of our galaxy isn't at the center of our local cluster of galaxies, so why would suddenly we be, as observers, right in the center of the known universe? So the other explanation is that everything is moving away from everything else, and that would give us the perception that when we look out into space, everything is moving away from us. And so to see that, you can use a standard balloon. So this is a little balloon I've got here, and what you can do is you can blow up that balloon, and you can draw some dots on it. And so, go ahead and just draw some dots on this balloon, and then watch what happens if you pick a dot, what happens to the rest of the dots as you begin to blow it up. All of the space between all of the dots in your balloon gets bigger. So that's a pretty amazing observation, because what that means is that the universe used to be smaller. Right? There was a time that there was less space between all of the galaxies in the universe. So the universe was once much smaller. All of the stuff between the galaxies, all the space between the galaxies, everything used to be closer together. But that also means that the universe is getting bigger. And that the space between all of the objects is getting larger. Now, provided that the universe is kind of infinitely stretchy, that's just going to go on forever, and eventually everything will be so far apart that we won't even be able to see it anymore. But that's the question that we have this week, is what is the evolution of the universe? Now, it also indicates that the universe had a beginning, and that's something you did last week when you measured the age of the universe, measuring this expansion rate. And so the fact that the universe has a beginning implies that it also has an end. And that's what you're going to be learning about this week, the evolution of the universe. The really cool thing about this particular concept is that physics really has a good idea of what happens to things as they get packed tightly together. So if we kind of wind back the clock and look at what's happened as we go back towards the origin of the universe, you'll find that things get hotter, things get denser, and that we have laws of physics that will explain what happens. And so what you'll be learning about this week is how as the universe cools, we get the first subatomic particles, we get the first elements, those elements form into the first stars, those stars synthesize new elements, you eventually get galaxies, and all of that comes out of just a cooling gas, which is pretty amazing. Now, of course, there's what's going on before the beginning of the universe, and that right now physics has no way of knowing, because all of our laws of physics basically cease to operate before the origin of the observed universe. And all we can say is, well, we can study everything after that, and that's okay. So that's what you're going to be learning about this week. You'll also be learning about what happens as the universe expands, whether it's going to expand indefinitely, whether it might get to the point where space-time is not strong enough to hold back the expansion and it pops. That's what you're going to be learning about this week. So enjoy.